Yes, now hopefully it is visible.
Yes, sir, you are visible now.
Yes.
Yes, sir.
Okay. So, okay. So, uh, let's talk about the skewness. Uh, Whenever if you see the perfect, if you have a look at the perfect normal distribution, you will see that it is symmetric in nature. The two half, it looks just identical, just opposite but identical. Okay. So any departure from symmetry is called skewness. And in a perfectly symmetric distribution, that means in a perfect normal distribution, you will have mean is equal to median is equal to mode. Okay. So you already know the concept of mean. Mean is the average. Okay. Uh, and median, it is the middle value of a series of data. It is the middle value of a series of data. And the mode, it is actually, you can see that the mode is the most frequent values. Okay. So when you talk about symmetry, the data may be positively skewed or the data may be negatively skewed. So if the curve has a longer tail towards the left, then it will be termed as, it is said to be uh, positively skewed. Okay. And when, if the curve has a longer tail towards the left, okay, it will be said that it is negatively skewed. So this is negatively skewed. You can see that the longer tail, okay, at the left side, and this is positively skewed because the longer tail, it is on the right side. Okay. So basically, uh, whenever you can see that median for symmetrical distribution, negatively skewed and positively skewed, for all the data, negatively skewed means for all the distributions, the median, it is just the middle value. Okay, there is no change for all these three cases. But the position of mean and mode, okay, those have been changed. Okay. So here, in case of positively skewed, you can see that most of the data here the most of the high value data, in case of positively skewed, you can see that there are more observations below the mean than above it. Okay, more observations for positively skewed when the mean is greater than the median. In this case, in positively skewed value, you can see that the mean value, it is greater than the median, and in case of negatively skewed, the mean value, it is actually less than the median. Okay. So automatically you can see for the positively skewed, most of the data, they are actually below the mean. Okay. Because why? Because mean is greater than median in case of positively skewed. So most of the data are below the mean. But since in case of negatively skewed, mean is less than the median, so most of the values are, or most of the outcomes are actually, you can see that they are above the mean. Okay. So this is the concept of the symmetry, uh, or sorry, skewness. And next, after skewness, you can see that it is to be corrected. Actually, here it is written that positively skewed, if the curve has a longer tail towards the left, it is said to be negatively skewed. It is not the definition of negatively skewed. Negatively skewed is here given. It is positively skewed. So the definition should be corrected. Actually, the definition will be that if the curve has a longer tail the towards the the right, it is said to be have positively skewed. Okay, so this should be right and this should be positively skewed. Okay, so another terminology you will see, that is which is known as the kurtosis. Okay, so it is nothing but the pickedness, okay, of the uh, distribution. Okay, you can see that here the distribution is equal to 3. It is more, pickedness is very high, greater than 3, and here it is less than 3. This is nothing but the pickedness, nothing else. So now you can see that there are some other terminologies like histogram, normal QQ plots, and box plot. Okay, so let's first talk about the histogram. Okay, so you already know about histogram, that histogram is for continuous variables. Along x-axis you represent the outcomes, and along y-axis you represent the frequency density for a continuous distribution. So that is known as histogram. So later on we will discuss more on it. Okay, so now there is another terminology we have seen, that is normal QQ plot. Okay, normal QQ plot, it is actually the QQ plot, it is known as the quartile plot. Okay, so sorry, quantile plot. Okay, so what is quantile? First we can see. Okay, so here you can see that this is along x-axis. Okay, some one particular gene expression has been represented by the data. This is a series of data. All the gene expressions are given. Okay, so in general, quantiles are just the lines that divide data into equally sized group. Okay, suppose you have some series of data. So quantile are just the lines that divide data into equally sized group. So all these are actually known as quantile. That's the technical definition. And technically speaking, percentiles are just quantiles that divide the data into 100 equally sized group. So when you talk about percentile, so that means you are dividing your data equally into 100 equally sized group. So that is actually known as the percentile. And quantile, it can be any number of group. You can divide your data equally into any number of groups. Okay. So any equal number of group is represented by quantile, but if you divide it 100 equally group, then it will be termed as the percentile. Okay. So suppose here you can see that there are 15 data points. Okay. Now we just have a look at this line, this data. Okay. And this line. So underneath it, there are 3 data. That means 3 data has the value below it. So this data point is the 3 divided by 15. Why 15? Because there are a total number of 15 data points are there. So 20% quantile or the 20th percentile, you can say. This data point is the 20% quantile or the 20th percentile, you can say. Okay. And what is QQ plot? The QQ plot below, it is a quantile plot. Okay. You just need to know that there are some methods of how to do this quantile plot. But here you just need to know that if suppose you have got a data, okay, a series of data, and suppose you want to check whether that data is normally distributed, you can have the QQ plot or quantile plot of the data. And if you see that the QQ plots it is distributed almost in a straight line, then you can say that your data is normally distributed. Or if it is not like that, then you can assume that your data is not normally distributed. Suppose here this is a straight line. If your QQ plot is like this, okay, so you can see that that data is not it is not the normally distributed. Okay, in case of normal distribution, most of the data points will be in a straight line. Okay, will be around the straight line. Okay. So, but usually these are not very much required actually. The QQ plot or the skewness or the pickedness or kurtosis, these are not very required for this. But one thing is very interesting, that is actually the box plot. Okay, the box plot. Box plot looks like this. This is very interesting. To why box plot is used and why box plot is very interesting, I am telling you, because the first thing is that box plot explains that how your data is distributed. This is one thing. And the second thing is that box plot or box Biskin's plot, this also tells you that whether there is any outlier in your data. Okay. So first let's take a look at the example. I think it will be easier if we go through an example. Suppose you have got this data 5, 6, 12, 13, 15, 18, 22, 50. Okay. So how can you make a box plot of this data? Okay. So you can see that 1, 2, 3, 4, 5, 6, 7, 8. This is 8 numbers are there even. Okay. Usually if it is odd number, if you have odd numbers, then it becomes very easy like this. Okay, 1, 2, 3, 4, 5, 6, 7. So you can very easily identify that this is your Q2. Okay. or this is your quartile. Okay. See, before that, I would like to say you one thing. What is the difference between quantile and quartile? Okay. You must understand that quartile is also a quantile. Okay. Quartile, it is also a quantile. But all the quantiles are not quartile. Why? Because quartile only indicates those quantiles if your data is it divides if there are 4 divisions. For example, suppose in this data 3 4 4 5 6 8 8, there are 1 2 3 4 5 6 7, there are 7 numbers you can see. So your middle quartile would be, it is Q2, it will be your Q2, and your lower quartile, this will be your Q1, and Q3, this will be your upper quartile. And you can easily understand that you are dividing it 1 2 3 4, equal 4 divisions. Okay, so that's why it is when you are dividing it into 4 divisions, that means it is quartile. Okay, so obviously quartile is also quantile, but in case of quantile, you may divide it into 5 divisions, or you may divide it into 10 divisions, whatever you wish. And in case of percentile, I have told you that you generally divide it into 100 equal divisions. We assume it. So anyway, here we can see that how to do this. But whenever you are having, here in this case, you can see that there is odd number 1 2 3 4 5 6 7. There are 7 number of data. But in this case, this is not 8 numbers are there. So this is even number. So in the even case, you need to find out the value of Q1, Q2, and Q3. Q1 is lower quartile, Q2 is middle quartile, and Q3 is upper quartile. Okay. And obviously, before that, you need to arrange the data from small to large values. You need to arrange the data properly, 5, 6, 12, 13, 15, 18, 22, 15, this way. So your Q2 value, first you calculate, it is 13 plus 15 divided by 2, it is 14. Your Q1 value is 6 plus 12 divided by 2 is equal to 9. Your Q3 value, it is 18 plus 22 divided by 2 is 40 by 2 is equal to 20. Okay. So now you will be making your box plot. Okay. So along x-axis, this is your graph. Okay. 1 2 3 4 5 6 7 8, like this. Okay. And you will put your Q1 values, Q2 values, Q3 value. Okay, in this way you will make your graph. Q2 is actually nothing but your median. Okay, you can easily understand Q2, it is nothing but your median. Okay, because it is the middle value. Okay. Now you should find out the IQR, or interquartile range. Okay, how to find out the IQR? IQR you should find out in this way. IQR is given by Q3 minus Q1. Okay. So in this range of data, IQR is equal to Q3 minus Q1 is equal to 20 minus 9 is equal to 11. This is your IQR. Okay. Now you need to find out what is the value of 1.5 into IQR, Q1 minus 1.5 into IQR. Okay. So you have found out the value is minus 7.5. Q1 minus 16.5. That means 3 into IQR. 3 into IQ, sorry, 1.5 into IQR. This is equal to 16.5. Okay, so Q1 minus 16.5, that means 1.5 into IQR is equal to minus 7.5. And Q3 plus 3 into IQR, this is your 16.5. This is equal to 36.5. Okay. So you have already found out the values of Q1 minus this I 1.5 into IQR, Q3 plus I 1.5 into IQR. So this is basically, you can say that this is your lower bound, and you can say that this is your upper bound. Okay. So this is your lower bound and this is your upper bound. Okay. So any data in this particular series, if it lies beyond this lower bound or upper bound, that will be treated as an outlier. So you can see here that 5, 6, 12, 13, 15, 18, 22, all these data are within this range of minus 7.5 to 36.5. So they are not outliers. There is no outlier. Only the 50, it is beyond 36.5. So 50, this data point will be treated as an outlier. Okay. There is a wrong diagram actually. It is here. It is the Q1, Q2, and Q3 values are plot. This box plot diagram has been made. Okay, but here actually they have here somebody has shown it from 50. Here it is 50 and here it is 5. But it is not, it is actually wrong, because it will not be extended. This line will not be extended up to 50. This line will be extended up to 36.5. Okay, because these lines are actually representing, these points are representing actually the lower bounds and upper bounds. Okay, they not necessarily that they will represent the smallest value or the highest value of this series. Okay, of this series. Okay, but here why the diagram is wrong, because when they drew the box plot, they have shown that your 50, it is they have not these tails. Okay, these tails are not showing the upper bound or lower bound. These tails are showing just the lowest data of the data series and the highest data of the data series. This is actually wrong. This is not the box plot. You need to extend it up to 36.5, and on the left side you need to show it up to minus 7.5, up to minus 7.5. So that will be your box plot. Okay. So now it is less than 1 minute. So again, we can join. Okay. And from this box plot, you can also see that how your data is distributed. Okay. You can see, you can easily calculate the mean value of this 5, 6, 12, 13, 15, 18, 22, and 50. Okay. You can check out the mean value. Okay, it will come out to be, suppose if this value is less than your median, then you can see that